So hello students, this is Palash Murthy B, Assistant Professor in Department of Mathematics, Government Science College, Chitradurga. Yes, in earlier session we discussed the triple integrations, evaluation of triple integrations by changing the variables. So in that one, we discussed two important transformations: cylindrical polar coordinates, Cartesian to cylindrical polar coordinates, and Cartesian to spherical polar coordinates. So in 13th session, I discussed a problems in cylindrical polar coordinates by changing Cartesian to cylindrical polar coordinates. In today's session, I am going to discuss a problems on changing Cartesian to spherical polar coordinates. So this is the 14th session and this is the last sessions of this calculus fourth part. Okay, let us see some problems and corresponding things here. Yes, a triple integrations f of x y z into dx dy dz can be evaluated by changing x y z into some variables. Yes, here you see these problems. So evaluate triple integration over r x y z into dx dy dz over the positive actant of the sphere x square plus y square plus z square is equal to a square by transforming into spherical polar coordinates. You know how that x, y, z are related to the spherical coordinate system, that is rho, theta and phi. So that is x is equal to rho into sine theta cos phi, y is equal to rho sine theta sine phi, and z is equal to rho cos theta. Okay. As first you consider that given sphere, that is x square plus y square plus z square is equal to a square. As you know that this is a sphere with center, origin and radius a. Okay, you write the corresponding x, y, z in terms of rho, theta, phi. So that is expressed in the equation 2. Okay, so then we already solved that Jacobian j is equal to rho square into sine theta, and dx dy dz is equal to j into d rho d theta and d phi. So that j is rho square sine theta into d rho d theta d phi. As we use the equation 2 in 1 equation, you use that equation 2 in equation 1. So then we have that is if we squaring and adding all x y z, if we squaring and adding all x y z, it gives that rho square. You just go and check that value. If you want, you just go and check that values. X square plus y square plus z square, it gives, which is equal to rho square. Okay, so if this is a rho square, x square plus y square plus z square is equal to rho square, so then it is rho square is equal to a square. Then it becomes rho square is equal to a square. So if you cancel this square on both sides, then rho is equal to a. So you obtain that rho is equal to a. Again, so to cover the positive actant, that is the positive actant of the sphere, so all x, y, z are positive in first actant. So here the theta varies from 0 to pi by 2, and phi is the angle phi varies from 0 to pi by 2. Rho, that is the radius that varies from 0 to a. So then correspondingly you take its limits 0 to a, 0 to pi by 2, 0 to pi by 2 into x, y, z. So you know that x is rho sin theta cos phi, y is rho sin theta sin phi, z is rho cos theta. You substitute all that x, y, z values here. So rho sin theta cos phi, rho sin theta sin phi, rho cos theta into dx dy dz is rho square sin theta d theta d phi d rho. So now we are to simplifying this rho into rho into rho into rho square, that is rho to the power 5, and next it is sin theta cos phi. So you see, so this is so okay, now it is sin theta into sin theta is sin cube theta, sin theta into sin theta into sin theta is sin cube theta, and this is cos theta, and also this is sin phi into cos phi. Sin phi into cos phi is written here. It is sin phi into cos phi into d theta d phi d rho. So first integration is with respect to theta. So first we have to integrate this with respect to theta. You notice that so I think you know this formula in integration. In integration, so integration of fn of x into f dash of x dx is equal to fn plus 1 of x by n plus 1. ಸೊ ಅಂದರೆ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ನ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಇಲ್ಲೇ ಇದ್ದರೆ ನೀವು ಅದರ ಇಂಟಗ್ರೇಷನ್ ಏನಂತ ಬರಿಬೋದು. ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ಸ್ ಇಂಟಗ್ರೇಷನ್ ಇಸ್ ಎಫ್ ಆಫ್ ಎನ್ ಪ್ಲಸ್ 1 ಎಕ್ಸ್ ಬೈ ಎನ್ ಪ್ಲಸ್ 1. You see differentiation of sin theta is cos theta, so its integration becomes sin to the power 4 theta by 4 theta. Yes, okay, yes. So its integration in differentiation of sin theta is cos theta. ಇದರ differentiation ಇದರ ಪಕ್ಕದಲ್ಲೇ ಇದ್ರೇನೆ ಇದರ integration ಏನಂತ ಬರೀಬಹುದು, sin to the power 5 theta by 5 theta. You can write sin to the power 5 theta by 5 theta. Integration of sin to the power 4 theta is sin to the power, this is 5, this 5 divided by 5, sin to the power 5 theta by 5 theta. And you substitute that values, sorry, I have to make it is 5 sin 90, sin to the power 590, this is sin to the power 590. See what that is, sin cube theta or yes, sin cube theta is there, so it is correct. It is integration is sin to the power 4 theta by 4 theta. Sorry, this is the value, we need to change this value. This is sin cube theta, so its integration is sin to the power 4 theta divided by 4. So it is sin to the power 4 theta by 4. You apply the limits. Sin to the power 4 pi by 2 by 4 minus sin to the power 4 0 by 4. So now, so sin 90 is 1. 1 to the power 4 is 1 only. This is 1 by 4 minus 0. So take this 1 by 4 constant outside from the integration. So 1 by 4 into 0 to a. 0 to pi by 2 into rho square into, and you see this sin phi into cos phi. Sin phi into cos phi can be written as sin 2 phi by 2. You write that here, sin 2 phi by 2 into d phi d rho. Next integration is with respect to phi. Integration of sin 2 phi is minus cos 2 phi by 2. 2 into 2 with limit 0 to pi by 2. So next step you apply the limit rho to the power 5, and this is the 4 into 4 becomes 16. 1 by 16 into minus cos 2 into pi by 2. This is 2 into pi by 2. Okay, that is 2 pi by 2, no problem. Plus minus of minus becomes plus cos 0 into d rho. So this 2 cancels, remaining is cos pi. Cos pi value is minus 1. Minus 1 of minus becomes plus 1. 1 plus 1 is 2. So it becomes 2 by 16 into integration of rho to the power 5 is rho to the power 6 by 6 with limit 0 to a. In next step you apply the limit. So it is 1 by 8 into a to the power 6 by 6 minus 0. So again it is a to the power 6 by 8, 6 are 48. So a to the power 6 by 48 is the required value. Similarly, you see one more problem. Evaluate triple integration over r x plus y plus z dx dy dz, where r is the region in the first octant bounded by the sphere x square plus y square plus z square is equal to 4. 4 can be written as 2 square. So it is x square plus y square plus z square is equal to 2 square. It is a sphere with center, origin and radius 2. As correspondingly you write xyz in terms of rho theta phi. So then it is then it takes this one. So here j is equal to rho square into sin theta Jacobian, and substituting dx dy, and you see that dx dy dz values here, rho square into sin theta into d rho d theta d phi, and if you squaring and adding this, it gives that rho is equal to, so actually that rho is equal to not a, so this is 2, rho is equal to 2, rho value becomes 2. Okay, so then Here theta varies from 0 to pi by 2 and phi varies from 0 to pi by 2 and rho varies from 0 to 2. So okay, write the corresponding limits here: 0 to 2, 0 to pi by 2, 0 to pi by 2, x plus y plus z. This is x plus y plus z into rho square sin theta d theta d phi d rho. That is the first integration with respect to theta, then with respect to phi, then with respect to rho. So now you take this rho into rho, you take it as a common factor. This is rho into rho square is rho cube, and this is sin theta cos phi plus sin theta sin phi plus cos theta into sin theta d phi into d rho. We have to multiply this sin theta with these two terms, so then it gives that. So take sin theta common factor from these two terms and multiply this sin theta, then it is sin square theta into cos phi into sin phi plus sin theta cos theta into d theta d phi d rho. Okay, now it is so next you can write this sin square theta is half into 1 minus cos 2 theta, and sin theta cos theta can be written as sin 2 theta by 2 d theta d phi d rho. So now you can integrate this with respect to theta first. So integration of 1 with respect to theta is theta minus integration of cos 2 theta is sin 2 theta by 2 cos phi plus sin phi minus integration of sin 2 theta is minus cos 2 theta by 2. 2 into 2 it becomes 4 with limit 0 to pi by 2 into d phi d rho. You can use reduction formula also, because with limit is 0 to pi by 2. So you can use the reduction formula when you are integrating this. Okay. So next step we have. So if you apply the limit, it is like this: 1 by 2 into pi by 2 minus sin 2 into pi by 2 by 2 cos phi plus sin phi, and this is minus cos 2 pi by 2 by 2 into 2 minus of 0 minus cos 0 by 4. So next step, if you simplifying this is 0 sin pi udiyuttale, sin pi andre 0, pi into pi by 2 into 1 by 2 is pi by 4. So it is pi by 4 into cos phi sin phi. So in next step it is 1 by 2 into d phi d rho. So next integration is with respect to phi. So integrate with respect to phi. Rho cube as it is, pi by 4 is a constant, keep it as it is. Integration of cos phi is sin phi minus integration of sin phi is minus cos phi plus integration of 1 by 2 with respect to phi is phi by 2 with limit 0 to pi by 2 into d rho. You apply the limits here. So it is 0 to 2 rho square into this is pi by 4 into sin pi by 2 minus cos pi by 2 plus 1 by 2 into pi by 2 minus lower limit is 0, you put 0 in place of phi. This is 0, cos 0 is 1 plus 0. So simplifying this, it gives that 0 to 2 rho square into, so this is cos sin 90 is 1, cos 90 is 0. So 1 into pi by 4 is pi by 4 plus 1 by 2 into pi by 2 is pi by 4. Cos 0 is 1 into minus pi by 4 into minus becomes plus pi by 4. So pi by 4 plus pi by 4 plus pi by 4 is 3 pi by 4. Next integration is with respect to rho. Integration of rho cube is rho to the 4 by 4 and apply the limit. Its limit is 2 to the 4 by 4 minus 0, and simplifying this 2 to the power of 4 is 16. 16 by 16 cancel, remaining is 3 pi. So like this we can evaluate the triple integrations by changing into spherical polar coordinates. So if possible, try to solve this problem. Evaluate integration from 0 to a 0 to root of a square minus z square, 0 to root of a square minus y square minus z square to x square plus y square plus z square into dx dy dz. So by changing into polar coordinates, so you may get its answer is pi into a to the 5 by 10. Okay, so thank you. So this completes all the parts of all the portions of line and multiple integrals. So the triple integrations portion is finished. Thank you.